Am I really that much? And
Hi everyone, this is Lisel Ruaya from BSCS 2A. Today, we'll analyze a simple yet important problem, which is the finding of odd numbers in an array. We will break it down step by step and understand its time complexity. But first, let's quickly review what is an algorithm and time complexity mean. An algorithm is just a set of instructions to solve a problem, just like a recipe. It tells you how to cook a meal. An algorithm tells a computer what steps to follow to get a result. The complexity describes how fast an algorithm runs as the input size grows. We measure this using big O notation, which helps us compare different algorithms' efficiency. Now, let's move on to our main problem, which is finding all odd numbers in a given array. Let's say we are given an array of numbers, and we want to find and list all of odd numbers inside it. How do we do that? Let's break down this step by step. Step 1. Start at the first element of the array. Step 2. Check if the number is odd. If a number is odd, it is not divisible by 2. Step 3. If the number is odd, store it or print it, otherwise skip it. The last step is move to the next number and repeat until the end of the array. So, that's our 4 steps on how to find all the odd numbers in an array. So, let's apply this to our example. So, this is our given array example as 3, 8, 5, 12, and 7. First, we have 3. So 3 is an odd number, so we need to keep it since we are finding all odd numbers. Next is 8. 8 is even, so what I have said earlier, we are finding all odd number. Since 8 is even, it is divisible by 2, so we need to skip it. And the 5 is an odd number, so we need to keep it. 12 is an even number, so we need to skip it. And the last is number 7. 7 is an odd number, so we need to keep it. Since we find all the odd numbers, so this is the final output. The odd number is 3, 5, and 7. That's it. We have successfully filtered out all the odd numbers from our array. For your better understanding, here is the sample Python or pseudocode to find all the odd numbers in an array. This simple code iterates through the array, checks for odd numbers, and stores them. Now that we understand the algorithm, let's analyze its time complexity. But the question is, how does the algorithm performance change as the array gets bigger? In the worst case, the algorithm has to check every element of the array. For an array of size n, we perform n checks, one for each number. Since checking whether a number is odd takes constant time, the overall time complexity is linear time complexity. This is how the formulas work. What does O of n mean? If we double the size of the array, the execution time will also double. This is what we call linear growth. But what about the space complexity? The space complexity depends on how we store the results. If we are just printing the odd number, the space complexity is constant. If we store them in a new list, the worst case is storing all n elements, so the space complexity is O of n. So that's all for the time and space complexity. This algorithm is efficient for small and medium size of a dataset. But if you're working with a very large of arrays, you might consider optimizations depending on your specific needs. That's all for today. Thank you for watching.
am I really that much? And